So here I'll be teaching you how you distinguish the E or the Z isomers in an alkene. Let's take a look at this example here. Right, you notice the double bond, and the first thing to decide if this molecule has an E or Z allocation would be to look at the double bond and cut into two parts first. And then at each of these carbon of the double bond, you look, do they have the same group here? What my finger is pointing to is an ethyl group, 2 carbon substituent, and for the bottom part is fluorine. So these two are different. And on the other side, you have a fluorine there, and this is an isopropyl group. So again, these two are different. Now, for each of these carbon along the double bond, if you have different groups here and different groups there, then you could have E and Z. It does not matter if you have the same group on the opposite side, okay? You just need to have different groups connected to the same carbon in the double bond. So let's look at these substituents, an ethyl against a fluorine. Who is of a high priority? For this, we need to use the fingers again and go atom by atom. Emerging from this carbon here, we go up, we reach a carbon. You go down one, you have a fluorine. So carbon's atomic number is 6. Fluorine's atomic number is 9. 9 is greater than 6, so you check fluorine as a higher priority, which is at the bottom here. On the other side, you go one bond, fluorine again, atomic number is 9. You go up by 1, you see a carbon, so that's a 6. So again, the higher priority is at the bottom. Now notice my ticks now are on the same side, which means that these belong to a Z isomer. For this molecule, this is actually another isomer for the one I've drawn here. If you see carefully, they are quite similar, and the difference is only that the fluorine position and the isopropyl position are being swapped. So we call this geometric isomer, right? Because the double bond, you can't rotate it, if not you have to break it, so these two are not interchangeable. Just imagine you take two markers here, right? Imagine they are the double bond, and then you try to rotate them. You see? It doesn't rotate. If I do it, I will drop my marker or break it. So this is not possible to interchange. Now for the molecule here, let's decide whether it's E or Z. So likewise, we know from here that fluorine is higher than the carbon. So we take here, and the fluorine over here is higher than the carbon of the isopropyl group. So you check here, and since the high priority are on the opposite side, so it's trans. In this case, we have an E.